Hi, and welcome to the Data Wranglers, a conversation about the latest trends in data engineering, hot takes, and insights on the data industry. I'm your host, Joe Hellerstein.
And I'm Jeffrey Heer. Today on the podcast, we'll welcome Sarah Catanzaro of Amplify Partners, who has some interesting insights and stories to tell when it comes to data and beyond. I think something about pirates, but we'll get back to that.
So, Jeff, apropos, perhaps maybe not apropos, I don't know, but I'm wondering, you got a rainy winter up there in Seattle. How are you going to keep yourself busy? Do you guys have like a favorite family game you like to play or anything like that?
Well, these days, my kids are, like many, into Legos, but really into card games, and particularly Sleeping Queens, which is a game invented by kids, and my kids absolutely love it. But maybe when they get a bit older, they'll adapt to some of the more complex board games, like Settlers of Catan.
Yeah, right. Settlers of Catan. I couldn't help being reminded by Sarah's last name of that game, so I did a little Googling. Turns out Settlers of Catan is a German invention. It's a German game, but I did enough Googling to learn that Catanzaro is actually an ancient city in Sicily. And so maybe as we meet Sarah, we can learn a little bit about her roots. So that brings us to today's guest, Sarah Catanzaro. Sarah's a partner at Amplify Partners, one of the partners, I guess you'd say, where she focuses on startups that bring technological advances in machine intelligence and enterprise infrastructure to solve real-world problems. Now, Sarah's had an amazing, multifaceted career. I strongly encourage folks, Google her webpage at Amplify, where she writes really interestingly about how the 9/11 attacks spurred her to pursue a career in data analytics and national security. And this led her into jobs in the U.S. Secret Service and Palantir after graduating from Stanford at the Center for International Security and Cooperation as an honors scholar. So we are super proud and excited to have you here on the Data Wranglers. Welcome, Sarah.
Awesome. Thanks for having me. I'm really looking forward to chatting today.
So Sarah, let's start with the pirates. So earlier you were a research director for the Center for Advanced Defense Studies. How did data relate to pirates?
Yeah, that's a great question. Ultimately, I think data can be used to understand so many phenomena, including kind of complex social networks, emergent behaviors. Most specifically, we were using techniques related to network analysis to better understand the flow of transactions and communications among Somali pirate networks. Uh, Somali pirate networks are actually very kind of complex networks and complex systems because there are elements of business relationships in terms of how some of the pirate groups were financed. But Somalia also has this very intricate clan structure where you have, the clan, sub-clan, sub-sub-clan, and I think it goes down like 12 different levels or so. And so we were using data on each of the individual pirates as well as these various affiliations to determine if we could predict how money, how directives would actually flow through these networks so that we could disrupt them accordingly.
Well, that's fascinating. It reminds me, one of the first times I connected with industry, I was actually a grad student. I started talking to DJ Patil way back in the day when he was at PayPal, and he similarly was mapping out the social networks of transactions, but really with the goal of finding fraud. And those kind of very specific motifs that would show up in the network that would indicate fraudulent actors versus sort of standard transactions. I'm curious if you saw something similar among the pirates that was allowed you to gain some insight there.
Yeah. As a kind of an aside, I think one of the things that I've noticed is that so many of the like early data scientists in industry actually have roots in kind of like the computational social sciences. We're really kind of focused on understanding how either criminal networks or social networks or other constellations of like people and the groups to which they belong would behave and could behave. With the Somali pirate networks, we weren't necessarily looking at kind of anomalies and trying to detect fraudulent behavior. Rather, we were trying to better. It was more kind of descriptive analytics. We were trying to better understand what some of the central nodes in the networks might be, what some of the so-called gatekeepers who, if disrupted would kind of limit the cohesiveness of the network, who those might be, so that again, they could determine kind of the right operations to conduct to really limit the power of those networks. And also, in the face of uncertain information, while we might have like a higher degree of rather certainty associated with the clan affiliation, we had intelligence on like some of the financings, but the intelligence was always associated with like varying degrees of confidence. So I think the just returning to what I was saying about data scientists coming from the computational social sciences, I think it was kind of that combination of being able to reason about data, but also reason about uncertainty, about data quality that really prepared us for roles in industry.
Yeah, I guess it makes a lot of sense. And, national security and criminal applications are not so different than business applications in a lot of these cases, too, I'm sure, in the sense that, you really do want to find points of leverage in a network of influence. Makes a ton of sense. So I see the trajectory of your career. You started actually much closer to national security and defense, and sort of migrated your way into the enterprise. I wonder if you want to talk about what you see that's different as you moved across.
Yeah, so I've gotten myself in a little bit of trouble in comparing, startups to insurgencies and saying that, both have incentives to keep their, behavior and their plans like covert. And so, really we're using data to predict like how they might evolve and if they can disrupt incumbents. Note to self, like, don't compare founders to terrorists. So.
Somali pirates remind us that pirates are not adorable, right? So this is something to avoid when you're making your analogies. Yeah.
Hey, speak for yourself, Joe.
Yeah. I mean, ultimately, I think like there are a lot of similarities because again, like with both groups, like the goal is ultimately to disrupt an incumbent, to reshape a market. Both do have strong incentives to kind of limit the amount of information that they share with the broader world. I think there are even elements of kind of like group psychology in that startups can benefit from creating very kind of cohesive ties and a sense of identity. So there's a lot that I think is very similar. Um, the biggest difference I'd say is kind of this overlay of markets on top of these like various types of organizations and organizational behaviors. Um, in the case of something like Somali pirates, the set of actors, the kind of like boundaries between those actors, it's relatively well known and established. You have your Somali pirate group, you have like the various government agencies that are like trying to intervene, you have the Somali civilians. In a space like machine learning, like what are the boundaries of the market? Who are the stakeholders? I think in certain ways it can be even more challenging to predict what will unfold because like there's so much lack of clarity in determining even like what are the participants in the game, let alone the rules.
Yeah, I like your sociological take on the tech ecosystem. And building on that, right now there's a lot of buzz in the market around the so-called modern data stack. And a lot of it driven from Silicon Valley VCs with new data startups. So what's exciting you in this space?
Yeah, so I think like the thing that is most exciting to me is thinking about what changes as companies adopt the modern data stack. As a data practitioner, I feel like I was waving the banner of data quality and investments in better data management tools for years and years and years. And it finally feels like we're getting to the point that not just data teams, but their stakeholders really understand that like it is important to have high quality, well modeled, well documented, well monitored, well tested data. I think for that reason, you see the rise of modern data stack and these set of tools that are really focused on enabling companies to kind of create great data models, great metrics. Um, but a data model or a metric alone like doesn't create value. It's in fact like the analysis of that data, um, or its transformation into a new product experience that creates value for companies. And so, the thing that I'm excited about now is really thinking about like, what does that entail? If there's this pendulum that I see in the data space, it's one that swings back and forth between focusing on the data and then focusing on analysis and modeling. And so the question that I've been trying to answer is like, when you have better data, what new analysis, what new models are now possible? Like, what can you do differently with that data when it's of a better quality, when it's easier to find, when it's easier to contextualize?
What's new beyond being less wrong, which I think is typically one of the major motivators. Talking to friends in the industry, I remember saying they thought like, yeah, that like they get things 10x wrong probably all the time. And so not just the data quality, but one of the things I really appreciate what you're saying was also well-tested data. And so I'm curious if you could speak more to what you're seeing that's going to be innovative in that direction.
So I think like what I've seen is there's certainly an explosion of tools associated with the data observability space. Um, but what's interesting about the data observability space to me is kind of the growing sentiment that like monitoring is not enough, that we don't need to be passive participants in the modern data stack, that in fact there are a lot of issues that end up impacting how wrong we are, that are introduced by data teams themselves as they iterate on their data models, as they iterate on their data pipelines. And so, it's not just a matter of like taking raw data and turning it into something valuable, but also kind of adopting some of the engineering best practices to ensure that when you are making changes, you're doing so in a more principled way. I'm eager to see like data teams adopting more practices that look like CI/CD, that look more like change management, that really acknowledge that data quality is not something that we can always control, but it's at least something that we can occasionally control.
Yeah, that makes sense. It's interesting when you talk about the modern data stack. Amplify and you personally have invested in a number of pretty successful companies in this space, but you're obviously not alone out there. There's so many of these companies branding themselves modern data stacks founded in the last 12 to 24 months. Increasingly the image is less like a stack of blocks. It's more like Jeff's kid dumping out a big bucket of Legos, right? It's the modern pile of Legos that customers have to sift through and investors have to sift through. True, and of course, I'm sure you want the companies that you're investing into to break through and succeed. So, how do you see young companies sort of navigating the space, and what do you see customers doing to kind of figure out which pieces of this are most relevant to them?
Yeah, so it one of the things that I appreciate about my role at Amplify is that I focus on both the analytics and ML stacks. And so I have the opportunity to kind of like compare and contrast them. And at least for the past, several years, though those stacks have evolved like more or less independently. So you see like different phenomena in each. And so what I see in kind of the modern data stack that stands in contrast to the machine learning stack is that there is at least kind of consolidation or widespread acceptance of what the kind of key capabilities are that data teams need. So like, I don't think many data leaders would question the fact that you want some sort of ELT capability, some sort of data warehouse or data management layer, some way of transforming the raw data that you're bringing into the data warehouse into data models, maybe a metrics layer, maybe something associated with reverse ETL so that you can operationalize your data models, make them available where other business leaders are. Maybe something related to BI and maybe something related to notebooking. And I'm sure I am not mentioning several categories, but at least like there seems to be more buy-in around the categories. Whereas if you asked, five different ML leaders to define the key components of their stacks, my guess is you would get five radically different answers. So, I think the problem, though, that you now face in the modern data stack and analytics engineering community is more of one where, like, we've got the grocery list, but we don't know exactly, what type of apples you need, and may not, in fact, have like a complete recipe of how to put each of these together. Um, what I'm seeing and what I hope will, be true in both ecosystems is that one critical element of, how data leaders select tools in each of those categories can and should be, how well they integrate with other tools. And so I do believe that the rising tide will lift all ships, and that it is kind of the responsibility of some of the vendors participating in the modern data stack to make it easy for their customers to build a stack, not just to solve a point problem.
Yeah, I think that's a really interesting contrast that you draw between data ops and ML ops as well. So I want to dig deeper there as well. I think you mentioned integration as a shared need, but what else is overlapping? And what do you think is unique to machine learning?
I think it's hard to like reason about the ML ops stack and the ML stack without acknowledging too that like there are in many ways two different ML stacks that are emerging, or two different sets of behaviors associated with ML that are emerging. Uh, One that really hinges on unstructured data, and another that hinges on structured data. It seems like a lot of the kind of excitement in the research community is around like transformers and other model architectures that are really focused on um, images and text and data types that can be more or less modeled as sequences. Uh, Whereas, a lot of the activity in industry is still centered around tabular and time series data. But the set of tools that you would need for managing text and videos and images, it is going to be radically different in more dimensions than I can, enumerate quickly. Now, I think that the question of how the ML stack and data stack will overlap as it relates to structured data is a really interesting one. And I see kind of two different camps. I do see camps that are saying like you need to your data that you use for machine learning needs to be kind of like purpose built for machine learning. That a machine learning model is very different than an analytical model, or some sort of query or aggregation, which in many ways is also like a model. It's also kind of like a representation of the underlying data. um, then I also see others that say, like, look, we are expending all of this effort, testing and documenting and monitoring our data sets. Like, we should we should be using that as leverage. And so, like, why not treat our metrics? Why not treat our existing data models as features and just build models on top of that? And I think both have merits. If I were to think about in the world of like structured data machine learning, what the biggest difference is, I think I think in ML you iterate on your data sets much more frequently than you would for some sort of analytics project. Like you you don't iterate on the data sets that power your dashboards as frequently as you iterate on the data sets that power your fraud detection models. And that may introduce kind of its own set of technical challenges and opportunities.
So let me try out like a somewhat contrarian view of that and see how it lands for you. Maybe this was one of the perspectives, and you were just being diplomatic and presenting multiple. But one viewpoint on this is like features are attributes. You have things called feature stores, but you scratch the surface, and they're some sort of database, essentially, or metadata management system, if you prefer to think of it that way, that is materializing views of the underlying data. Whether that data is images or not, sort of doesn't matter so much because the features are essentially tabular, matrix-oriented looking stuff. What the machine learning community is basically learning is data management.
I think that is absolutely true. I think like the biggest gap in terms of like unlocking ML applications and in terms of like having a more standardized ML stack is kind of the time needed for the ML community to learn data management. Um, and I think like the fastest way to make progress on ML is probably to actually use the systems and artifacts that we're creating in the analytics space for machine learning models. It is to train models based on your existing DBT data models, based on your existing metrics. Again, though, I think there are slight differences in terms of like the workflows and patterns. So thinking about like a metric and a feature. When you look at like the metrics layer companies that are emerging today, they're very focused on this idea of metrics consistency and like everybody within your company should be using the same definition of MRR and the same definition of a subscriber. In ML, if you're trying to optimize a model for either model related performance metrics or certain business KPIs, you may actually want to iterate on that feature. So you're iterating on the feature, but the metric needs to stay stable. And I think it's some of those subtle differences that make it a little bit harder to adopt the same systems and processes for ML as you might apply in the modern data stack or in analytics engineering.
That's really interesting. I like that. One of the things I think we talk about a lot is how in more modern data-oriented environments, you're not building a reference data warehouse that is sort of one model of the business. That there's certain things that need governance and agreement, and there's other things that are very custom for specific use cases. And I guess you've projected that on machine learning versus analytics, and we can agree or disagree as to the degree to which these things align. But definitely that notion of like some stuff really needs to be common, and other stuff really needs to be custom, and you need to build data pipelines to serve all of that. If you're going to be sort of a vibrant modern organization, that resonates for me so much. And it leads me also to something I really wanted to talk to you about. It's still in this space of like, how do you help your companies kind of find their way to product market fit and to meeting needs, which is job titles. The users, the people who are going to, consume all this awesome stuff that we like to talk about on this podcast, that seems to be changing too. And so I just want to do like kind of wrap it around with you a little bit, get your initial feedback on some job title categories and maybe quick takes on how you see them being different. And then we can go back and we can get into some nuance. But like I want to pepper you a little bit if you'll forgive me for it.
Let's do it. Yeah.
So data scientist versus data engineer, is that a valid distinction?
Yes. Data scientist is doing science, data engineering is doing engineering. I realize that is an oversimplification, but I'd say like the goal of a data scientist is to produce models and analysis. The goal of a data engineer is to ensure that like the right data arrives in the right place at the right time.
Super, super. Well, it's nice when the names line up with what you want it to mean, because that's actually pretty rare. So let's try another one.
Yeah.
Data analyst is a job category that's been around for a long time, but kind of a new one is analytics engineer. How do you see analytics engineer fitting into all this?
So this is a potentially like spicy category. Now, I think part of the reason why analytics engineering emerged as a new category was that the data analyst title like started to feel like a dirty word. It started to feel like a more junior role where people weren't really valuing the work that data analysts were doing. At the same time, I think like many aspects of data engineering got easier with some tools to create data pipelines, manage those dependencies, et cetera. So like there was more and more of the data engineering skill set that like analysts could actually take on. So the analytics engineering role is different than the analyst role in that they're more focused on not just analyzing data, but also like translating the domain model for a business into a data model. And data modeling, I think, is a really important kind of skill that one needs to cultivate over time. But fundamentally, I think analytics engineer is not radically new. It's just a little bit of analyst, a little bit of data engineer, and a lot of like elevating a title that has been unreasonably like kind of denigrated over the past several years.
So you heard it here, folks. Data modeling is a really important thing. Sarah Catanzaro. And it's everybody's least favorite topic in class when they learn it. And most folks who are doing data science don't even know what it is. It's absolutely super important. Couldn't agree more. Let me throw one more category at you real quick. Machine learning engineer and or other titles in the machine learning space. What are you seeing there?
Man, I don't even know what an ML engineer is. Again, like talk about ambiguity in an ecosystem. At some companies, an ML engineer is really just a data scientist who does ML. And in other companies, an ML engineer is somebody who works with a data scientist to deploy their models. So, if anything, I feel like the title of ML engineer, it's probably a symptom of the fact that like deploying models, managing models in production is still really hard. And like maybe what we need is more of like the equivalent of an analytics engineer who can do data engineering work, but also analyze data in the ML world where there are people who can do the model building work, but can also do more to deploy and maintain their models in production with a better set of tools.
So, Sarah, I think you outlined multiple causes for all these different job titles. So, some is specialization, some of that really makes sense. And I think others also jostling for status within the ecosystem of our organizations. So, I'm curious how you see these jobs in the data ecosystem evolving over time. And maybe closer to home for Joe and I, what do you think traditional education like universities should be doing to help here?
Yeah, I think that's a great question. What I think I've seen over the past like 10 years or so is that like data practitioners are expected to do more and more. So you're expected to be great at data modeling. You're expected to um, know statistics, know enough of like linear algebra to find ML approachable. You're expected to be great at like communicating data. In fact, in many organizations, you also need to be able to design with data. Oh, and now you need to be able to like write apps to Kubernetes clusters. And it's just too much. Like it's too much. And I think every data practitioner who I speak to would kind of align with the sentiment of like, I spend more time doing this one thing when I really wish I was spending my time doing this other thing. Now, I think there are two ways to correct for that, and one is certainly better tools. And now I hope that, like in the next several years, at the very least, like some of the tailwinds around serverless persist, so that we don't have data scientists writing apps to Kubernetes clusters, and just like we saw in the analytics engineering discipline and with the rise of cloud data warehouses, like we don't have analytics engineers doing query optimization. I think there is a clear need for data tools that manifests in the number of things that data practitioners are expected to know and do. But complementing better tools is, I think, in fact, like a little bit more specialization. Um, One of the things that is kind of sad to me is that like data scientists haven't really had as much time to kind of evolve in their craft of like learning new methods and statistics. If you're a data scientist, like and you want to be able to do better science, then staying kind of abreast of new modeling techniques and new statistical techniques, I think is super important. Um, uh, I think this specialization may also end up kind of following bounds around like what is the final artifact that you produce. Um, for example, like you see this domain of like decision science, which is closely tied with like practices around experimentation. Um, the notion that like your job is to produce high quality decisions or enable high quality decisions, I think that helps you as an individual determine like, okay, what are the set of skills that I need to be leaning into more or less to produce better decisions. In contrast, if you are a ML product engineer, perhaps what you're actually doing is building products, building new features in the product sense, not the ML sense, like a new recommendation engine or a new search experience. Or some new personalization feature. The set of skills required to build better products with machine learning is going to be very different than the set of skills required to enable better decision making. So maybe the way in which like these roles can align is around the output.
Yeah, it's very interesting in a world where you also have plenty of people arguing for building ML products to enable decision making. So I'm wondering how you decouple those. My secret answer is always like much more training and data collection and experiment design, because I think we build these towers on top of these data repositories that may not support the questions or use cases that people want to put them to. But very curious to get your take on that.
Yeah, no, I think that is a great point too. Now it's funny because earlier this week or last week, my colleague Emily gave a talk on data science, kind of talking about why data science was a misnomer because like not all of data science is about science. Science implies experimentation, but I couldn't agree more that like data practitioners, I think, need more training in experimentation and experiment design. So this combination of like being able to very rigorously define your data sets and your data needs through better data modeling, and then being able to kind of rigorously define the experiments that you're running on those data sets, I think generally leads to good. So more science, more data modeling, that would probably be my key takeaway.
So, Sarah, you're a little unusual. You're not alone, but you're a little unusual as a venture capitalist who came up as a practitioner. You have sort of deep experience in this space of data science, with applications to all sorts of things, as we've heard about today. You're also unusual in the venture capital space, frankly, for being female. I wonder if you want to reflect on either or both of those concepts of being a technical-oriented VC and or a female VC.
Yeah, absolutely. I can take maybe one at a time. So I'll start with kind of being a technical VC. Um, I think like being a technical VC has probably like helped me in three different ways. The first, which is like pretty simple, is just like having high empathy for the founders with whom I interface. Like we share a common vocabulary, and can kind of like gloss over the things that like we clearly agree on, and speak a common language when we're navigating disagreement. Anytime I hear a pitch and there's like a slide on like the TAM for data and ML tools and platforms, I'm like, okay, go beyond that. Like, we don't need to talk about kind of this kind of market sizing question when I'm investing pretty like primarily in data tools and platforms, and you're building a company in this space. I think we both know that we believe that this market is going to be big enough. Um, so certainly I think like the sense of empathy and shared experience can kind of impact how those conversations unfold. Um, I think it's in so many instances in like early stage companies, the product is the business strategy, or at the very least, the product implies a business strategy. You don't just decide that like you're going to sell something top down, or decide that you're going to sell something bottom up. Like a product either lends itself to a top down strategy or lends itself to a bottom up strategy. And if you don't deeply understand, or if you don't superficially understand the product, then I think it's really hard to like provide valuable guidance to startups on how to navigate their business. Um, and then lastly, like I think just the ability to kind of like reason about uncertainty and what information you need to make a decision has also helped me as a VC. Like there are times where I'm like, I actually don't need high precision data to make this decision, or times where I'm like, okay, given where I am, given kind of how my team is thinking about this deal, I do need to go out and collect additional information to kind of get us over the line here.
Do you have, or did you bring a more disciplined data-centric approach to the partnership when you joined?
I don't think like it's necessarily a data centric approach, but I think like we apply information theory in very kind of subtle ways when we're navigating investment decisions. I think we are thinking about like what is the cost of acquiring additional information relative to the benefit that it will impart, relative to the risk of making a decision earlier or late. Um, I can't say necessarily that like that's been my impact entirely, but I think like I bring a different style of decision making to Amplify. Um, you had asked about being a woman in VC too, and I like to be point blank. I think like being technical has made it far easier for me to be a woman in VC. If I can like hold my own in technical conversations, then it's easier to like move past that hump of, oh, you work in venture? What do you do? Do you work in, marketing, PR? Those are all important functions, but like, no, if I'm telling you that I work for a relatively small, venture capital firm, or at least small in terms of team size, like the default assumption should be that I do investing. And that's just, one kind of anecdote where I think for female investors, like you have to you have to overcome that inertia, like make a stronger first impression. Um, and I hope that's changing. And I think with every woman who starts a company, who goes into venture, who sticks with it, it does change. But when I think even about like my own peer group in VC, there's so many people who churned out because they just got sick of those conversations where they're like, I've proven myself and I have to prove myself again.
Is there an informal support network for, within VC period, but particularly for the women who are involved?
Yeah, there are a lot of kind of connections that are being made through Allraise. I think they've done a great job of creating both formal and informal settings for women to kind of discuss their experiences and how they've navigated some of these challenges. Um, I think the other thing that I've found too is that like the women in kind of my peer group, like we have really benefited from the struggles and the work of women in the generations before us, who I think had to like spend most, if not all of their time really kind of fighting for their position and fighting to move ahead. But they have afforded us a bit more bandwidth then to actually spend on like mentoring and coaching and, advising other women.
It's worth saying, I guess, in context of that, of course, in the data space, we go back to Grace Murray Hopper, who's the inventor of COBOL, right? So there's awesome roots there, but boy, a long journey. You mentioned All-Raise. I'm not sure if everybody on the podcast would be familiar. Do you want to take a minute and just expand on what All-Raise is?
Yeah, of course. So Allraise is a nonprofit that was established, gosh, it's probably close to 5 years ago, which is really focused on having more diverse representation in both the venture and startup ecosystem. And it does so through programming. It does so through kind of peer groups and several other programs. So I think it's been a great way to both meet other women in venture and entrepreneurship, um, and to just find kind of occasions to both like celebrate each other's wins and help each other navigate obstacles.
So Sarah, in addition to talking about the industry and data, we also like to learn something unexpected people might not know about you. And so if we can go back to the town of Catanzaro, any good family stories from Sicily?
Oh man, I wish I could say that that was the case. The surprising thing about me, perhaps, is that like I am Australian. So I was born in Sydney. My family actually hails from kind of northern Italy on the Italian-Croatian border, and my grandparents. They were actually living in a town in now the former Yugoslavia, basically had the option to adopt communism or leave. They left, moved to Australia. So don't have great stories about Sicily, but I've got better stories about like kangaroos and
Yeah, no, I'm even more interested now. Please tell me about the kangaroo.
the Monica Rigotti, I think, like used to say that data science is just counting. So maybe I got my start, in data science counting kangaroos. Perhaps that was where it all began.
Thanks for joining us, Sarah. This has been super fun. Great to have you on the podcast. Again, we've been talking to Sarah Catanzaro, a partner at Amplify Partners. If you have a question or a topic you'd like us to tackle, reach out to us at datawranglers@trifacta.com.
To review and subscribe to the Data Wranglers wherever you find your podcasts. The Data Wranglers podcast is brought to you by Trifacta, the data engineering cloud. On behalf of Joe Hellerstein and the whole team, thanks for listening. I'm Jeff Heer. See you next time.